Hello and welcome to this video about applying transformations to function graphs. In a previous video, we saw how a transformation of a given function f is a process by which the graph may be shifted, stretched, or reflected across the x-axis to generate a new related function with fundamentally the same shape. Each of these individual processes is itself a transformation, and they may be combined in various ways to create more complicated transformations. Because functions behave much like numbers, just as the order in which we perform addition, subtraction, multiplication, and division matters, the order in which we apply transformations also matters. Let's look at the process for applying a combination of transformations to sketch the graph of a function. Suppose the parent function f of x is this graph made up of a quarter circle and a line. We will focus on the effect the transformations have on three key points on the graph of f: -2, -4, 2, 0, and 5, 6. Let g of x be the result of performing a combination of functions such that g of x equals -1/2 f of x plus 2 minus 1. We know from our previous work that g of x is obtained by applying three transformations. First, f of x is shifted left 2 units. Second, the resulting graph is vertically compressed by 1/2 and reflected over the x-axis. Third, the last result is shifted down 1 unit. As mentioned, the first transformation applied to f is a horizontal shift left 2 units. Focusing on our key points, notice that a horizontal shift did not affect the y values at all. However, all the x values are 2 less than previously. We can also see this in the table of values. When the output is 4, x equals -4, which is 2 less than -2. And when the output is 0, x equals 0, which is 2 less than 2. Similarly, when the output is 6, x equals 3, which is 2 less than 5. In general, we see that shifting the graph left 2 units is equivalent to subtracting 2 from all of the x values of the points on the graph. The second transformation is a vertical compression by 1/2 and a reflection over the x-axis. Focusing on our 3 key points, notice that these transformations did not impact the x values at all. However, all the y values have changed sign and are half of their original value. We also see this in the table of values. When x equals -4, the output is -2, which is -1/2 times 4. When the x equals 0, the output is 0. This is equal to 0 times -1/2. It's worth noting that vertical stretches and compressions, as well as reflections over the x-axis, do not affect points that lie on the x-axis. Lastly, we observe that when x equals 3, the output is -3, which is 6 times -1/2. In general, we see that vertically compressing the graph and reflecting it over the x-axis is equivalent to multiplying by -1/2 by all the y values of the points on the graph. The last transformation applied is a vertical shift down 1 unit. Again, focusing on our 3 key points, notice that a vertical shift did not affect the x values at all. However, all the y values are 1 less than previously. Like the other transformations, we can also see this in the table of values. When x equals -4, the output is -3, which is 1 less than -2. When x equals 0, the output is -1, which is 1 less than 0. Similarly, when x equals 3, the output is negative 4, which is 1 less than negative 3. In general, we see that shifting the graph down 1 unit is equivalent to subtracting 1 from all the y values of the points on the graph.